Can everyone hear me? Okay. If I drop, let me know. So I'm very glad to be here, especially to show you that yes, they do indeed also let women work in applied math and industry. And Laura will back me up on that this afternoon. I think our percentages are slightly less at this meeting than they are in industry, but it's still close. So I'll start with, just like everyone, telling you a little about my career. And then after that, in the United States is where I've always lived. It's a gigantic country. And if you work there or live there, you're on planes a lot. I live on one coast, my parents live on another, my siblings live in the middle. You're on planes. About a year ago, they changed the law. But before that, you had this time where you would arrive to your destination. They would say, turn off everything, and we'll be in soon. So you turned off your laptop, your iPod, all these things, and then you just sat there. And then you would land, and then you would taxi forever. And people would be very anxious. They didn't want to take other things out of their bags. So that's when they would start talking to each other. They didn't have anything else to do, and there was a deadline to when this conversation would end. So it was perfect that we could have this talk. And the biggest thing that came up is, what do you do? So I would say, I'm an applied mathematician. You get two answers. You get one, what is that? Or you get, wow, you must be really smart. I don't even know how to balance my checkbook. Because everyone equated math with accounting, and that's all that they thought it was. So I have you for even less time than the taxi time at O'Hare Airport in Chicago. So I will try and quickly tell you what else we do with applied math, knowing that you know we do a lot of things. And I think I have a little surprise in my talk, which is what my job is now is very unexpected. So I want you to think about all the things I've done and think about how you can put math in places that are really out of the box. And then finally, just a little advice or observations. Whoops. Wrong way. Okay. Like I said, grew up in the U.S., less and less common in applied math. It's the only place I've lived. My family spent a little time in Europe, but I'm as American as they get. My dad is a professor of engineering, and so I had an easier path than a lot of people, in that I was very encouraged once I showed an aptitude and interest in math. I went to college in California, and then after that I went and worked at an applied math company, and I probably know more, or an applied genetics company, and I know a lot more about tomatoes than any one person should really know. So if you need gardening tips, you can ask me. After that, I went to Bayer for a little while, and then I realized I really like doing this math and industry thing, but I don't have enough education. So I went back to school. I started at Sac State getting a master's, trying to feel my way into this, teaching, and then I went to Rice, which was an amazing experience. I met Fadil there. That's part of how I'm here. I met a lot of great people there. And then from there, I spent 12 years at Sandia National Labs. Last year, embarrassingly, I don't like to bring this up with people from other countries because the U.S. looked horrible, but there was a government shutdown, and things went very bad at places like Sandia. So I decided to leave, and I'm now at Intel. I've actually been at Intel for only 2 months. So my talk will be slightly different in that I won't be telling you a lot about Intel, but if you do want to know some things, we can talk during lunch, because I've had all my training recently, so I probably know a little more than I think. Okay, so this is the part where we're taxing, and I'm quickly telling you, look, I can do all these cool things with math. Protein phosphorylation. Basically, I worked on these projects that had to do with figuring out how do we improve disease treatments. Groundwater contamination. switch entirely. Especially the labs were concerned because they made a lot of messes that they needed to clean up. And there was a lot of math and trying to figure out how best to clean up these methods. So I did a lot of work in this area. Electrical circuits. I knew nothing about electrical circuits, and now I know more than I probably should, enough to be dangerous. Basically, we were trying to understand how do circuits react in hostile environments and make a computational model of that so that we could test using the computer instead of the lab. Oops, skipped over nuclear waste. In the US, we have a large number, about 100 nuclear power plants. And the Congress decided that they would terminate a big project that they had about where they were going to store all this nuclear waste. So they needed to figure out an alternative. Some guys, and they were all guys, that I worked with at Sandia figured out an alternative plan, but they needed some help with the logistics. So that's how I got involved in that project. Let's jump around again. Heart rate and blood pressure. How are they connected? Worked with some doctors. The idea here is to think about if you're squatting down or you stand up really quick and you're kind of dizzy, your heart and your blood pressure are very connected. And doctors wanted a nice model of this. I don't know how it is here, but in the US you often go in a doctor's office and they have these charts that show if you're this size you should have this heart rate, or if you're in a gym they'll say try and get to this heart rate. Those are all baloney because they put them all together using dogs, and people are not dogs, in case you didn't know. And we don't function in the same way at all. So the doctors wanted to try and put together better charts, and we helped them try and improve these models. For the last few years, I spent a lot of time working on the electrical grid, only in North America. It's crazy complicated. Partly because there are some wide open spaces, and partly because we're connecting a lot of things together. I did a lot of work with trying to understand vulnerabilities, big time on how to add renewables, where and how. And then this is really where a lot of the work I've done with uncertainty came in, where we had to plan operations given uncertainties. All right, I did all this work. And now I'm at Intel. And everyone in here knows Intel. Everyone probably has an Intel product or chip in front of them, in their pocket, more than one. I'm an applied mathematician. Yes, there's a lot of jobs there, but what group am I in? I am in human resources. I think it's really cool to tell you this at this meeting because every single company has human resources. They all need mathematicians. They might not be there yet, but they do. Intel is an extremely data-driven company. They love to back up everything they do with data. And the group that I'm in decided that they actually needed a mathematician, someone that could do real data science to help their group. So we work on problems like, how do we best recruit? How do we promote people? How do we retain people? So it's for me it's weird. It's kind of this chicken egg thing because I'm new and trying to learn about how the company works for my own career, but I'm also trying to learn about how the company works to do my job. So it's very interesting and it's very different. And if you asked me, do you think I would be here? I would probably say no. But it's also very cool. Mathematically, it's very cool because I'm taking a lot of the methods I did on all those other things I showed you, energy and engineering, and I'm putting them to something completely different. And so there's going to be a lot happening with the theory. There's going to have to be changes to these methods. I don't have nice defined physical bounds on the way people act like I do on the way a circuit acts. So I have a lot of challenges and interesting things to do there. So for me, it's fun. I've gotten some upturned noses about this, but I've also gotten a lot of wow, that's really cool that we're doing this. So it's so far fun. I'm 2 months in, like I said, so we can talk next year too. Okay, so I've had kind of a very diverse list of problems, and these are the things that I've learned that work well for me. Some of them have come up, and I'm going to repeat them, and I think I might be saying slightly different things. All these areas that I've talked about, I didn't know anything about them with the exception of biology. I knew some biology. What did I know about the grid? When I turn on the light, it comes on. That's all I knew. But if you partner and collaborate with experts in other fields, they'll teach you. And it's awesome. I now know a little bit about a lot of very interesting things. And they think what you do is cool too, and then you figure out new things together. I think I've hit home that think about non-traditional applications. Don't just think about, oh, this company does this and they would never use math. Everyone uses math, whether they know it or not, and you can always convince them to use it, and you can show them and demonstrate how much you can help them. So think about it that way. Take every single opportunity that you can. Some of them might seem weird. So it might be strange that, oh, you're going to Korea, it's a 12-hour flight, it's a 16-hour time change, and you're going to be there 5 days. It's great. I get to see a new country, I get to meet a lot of new people, and I get to experience something different. I think Bogdan talked about PIC yesterday at WPI. Susie, that runs that program, over the summer, she made a documentary about mathematicians in industry. And I was one of the stars of that video. It was a very weird day for me. I've never gone to hair and makeup before I went to work. But it was fun, and I learned a lot. It was very interesting, and afterwards I got to talk to all of our students. And that video will be out there, and we're going to do some other work with it, so that's exciting. So there's all kinds of things. People might ask you to review something. Done a lot of trips to DC to do work for NSF in the United States. Met great people there that have called me to do other things later. I mean, you just don't know. So really take every opportunity that you can. The other thing that is I can't stress enough is have a very big, diverse network. When things were going bad for me at Sandia, I had a ton of people I could talk to, either to help me find a job, to help me get through what I was going through at that time, to help me manage this, to give me other opportunities, like, you know, I went to do this video, or I was on an organizing committee, so I could still do some activities. Even though things at work were not so great, I was still doing things in my career and moving forward. Definitely don't get in a rut. If you're not happy, make a change. Change is hard. It's really hard. But if things are not working, change. You don't necessarily have to leave your company. You might move around within your company. You might need to change something else, but change. It's important. A lot of the speakers here have seen very drastic changes, and it's important. In large corporations especially, but everywhere, even small ones, your manager is so key to your job. I can't stress it enough. I mean, at times when things were great for me, I had a terrible manager and it made it difficult. And at times when things were difficult, I had a great manager and it made it manageable. So it's important, and have kind of a plan, because companies reorganize a lot. And this is why people leave. Your manager, if your manager is good, they're going to move up and they're not going to be your manager anymore. So this is where you should have a network and figure out who you can work for and who you can work with. It's really important. And then the last one is really don't let your life dictate what your job's going to be. I think someone this morning said take chances, move around if you have to, if you can. But on the other hand, don't let your job dictate your life either. I think one thing about being female is that I was pregnant during my job. I have a 2.5-year-old now, and I had to figure out how to manage this. So every woman does. I think Korea is far more civilized than the United States about how much time off they give to people that have had a baby, but that still doesn't mean that you're not away from your job for an amount of time and you have to figure out how to manage these things. The other thing I can say is that my husband now, it's been 6 years. 6 years ago, my husband was diagnosed with cancer. He's doing great now. But he was very sick. He needed to go to a lot of treatments. And I was working, and I was really in my career. And I had to figure out how to balance this too. Fortunately, this is a time where I had an awesome manager, and it really helped. But, I mean, these things come up. And this is also where your network helps. Talk to people. I work with the Association for Women in Math. We do an online mentoring. You can be from anywhere. If you need to talk to people and get ideas about how to handle balance issues, do it. Talk to your coworkers, talk to people at other companies. If you have something big going on in your career or something big going on in your life and you need to work out something with the other one, you have to do it. So finally, the last thing is, like I said, I have a pretty big network. This is a few people that were on a few of the problems, on the problems that I showed. I just want to show you these names and the variety of places that they're from, because it gives you an idea that you really do work with a lot of people, and you should always acknowledge them. And a lot of times people will acknowledge you and then someone will call you. So I always acknowledge all my coworkers. And I want to encourage everyone in here to get in touch with me if you would like. I'm in LinkedIn with this Gmail address that's up here. Please connect with me. I use it. This is how I got a job. This is how I've gotten many interviews. ResearchGate is another thing that's growing. If you haven't looked into it yet, there's a lot of papers there. I'm trying to get all my papers in and things like that. So it's another place that you can find me or work that I've done. But I encourage you to connect with me. And I wanted to leave a few minutes to answer any questions. I'm happy to answer anything in this forum. I will be here for the rest of the meeting. I'm happy to answer at a break, at lunch, or definitely contact me. I'm very happy to talk to people about my experiences and their experiences and try and connect people. So thanks.
Questions in this forum?
Yes. Do you know how many mathematicians are there in the human resources of Intel?
You're looking at her. So the rest of my team is they're industrial and organizational psychologists. So they've had some statistical training, but they've had no math, and that's part of why I'm there. So yeah, my large team is 30 people. My small team, there's 6 of us, but I'm the mathematician. So yeah. So, when I was trying to figure out, this is actually a little bit of a long story, but when I was trying to figure out what I wanted to do, my dad said, you have to go meet this woman, she's amazing. Her name is Mary Wheeler, some of you probably know her. At the time, she had just moved from Rice to UT Austin. So I went there, and I met her, and she was like, okay, this is what we're going to do. Or if you know Mary, she said, 1, this is what you're going to do, 2, okay? And she said, okay, you need to meet this student of mine. Her name is Monica Martinez. And she showed me that she's working on this very cool thing, and I was like, all right, this sounds great. So I went to school. Monica graduated when I started, so we didn't overlap. But then when I went to Sandia, Monica was there. She left I went to Intel in around 2008. And then my current manager recently called her and said, help. We need help. We need help from a mathematician on these problems. And so she met with her and said, this is not, I can help you in one day. This is a job. This is a position. And I know a perfect person for it that's looking for a job. So that's how I got there, through my network. So, which was also good for Monica, because when you recommend somebody, you get a little bonus. So, yeah.
Excuse me.
Yeah.
So to follow the first question, does Intel use SAP?
Yes.
SAP,
Yes.
SAP has a lot of mathematician and data learning people.
Yes, they do.
Tons.
Yeah, and Intel is very involved with the HANA, which is with the cloud. Yeah, I just actually visited SAP to learn more about it a couple weeks ago. Yeah, there's a lot of other places in Intel that I could definitely work. This is just was the perfect place for me to go in right now. Yeah. Yeah, we can talk about SAPs. Yeah. Yeah, SAP, they're doing a lot with analytics in general. Yeah.
Okay, thank you. Thank you,
Thanks.
Genetha. One suk from Samsung.